So in question number 9, this is about rectification. We are told that figure 4 shows the input and output signal on a CRO screen when two diodes are used during a full wave rectification. Explain how the two diodes rectify the input signal. So we are using two diodes. There are two types of rectifications. First of all, what is meant by rectification? Rectification simply means converting an alternating voltage into direct voltage, or an alternating current into a direct current, AC to DC. That is what we mean by rectification. In the rectification process, we usually use diodes. We could use 2 diodes, or we could use 4 diodes. The situation where we use 4 diodes is referred to as a bridge rectifier. But here we are restricted to using 2 diodes. So there is only one way we can do this. We need to use a center tapped transformer. And then the connection will look like this. This is how the connection looks like. So first of all, let's note that a center tapped transformer must be used. The 2 diodes are connected in such a way that each conducts a current through the load resistor during a particular half cycle. The circuit is of course shown in this figure. So this is it. This center tap, this line here, is connected to half the number of turns of the secondary. Half the number of turns. Let's see. When point A is positive with respect to point D, that means for this half cycle, all the way from here to here, if we draw a line here, we can assume that the voltage above that line are positive, while the ones below the line are negative. So when point A is positive with respect to point D, it means that current is flowing in this direction. You'll find that diode D1 is forward biased. It will conduct, but D2 is reversed biased. So this current, when it reaches this point, there is no way it can flow through this route because D2 is reversed biased. So it will take this route and flow through the resistor this way. Let me get the cursor. So it will flow. So remember, this is it. That one conducts. This one does not. So the current is going to flow through the resistor this way. And it will come this way, but it can't take any other route from there. It will have to go back to A. So for that part of the cycle, this part of the cycle, the energy will have to be conducted through the resistor. In other words, current will flow. For the other half of the cycle, that is this particular half here, you find that first of all, with the red line here, A is positive and D is negative. That means D2 will not conduct while D1 conducts. Let me change here the color so that we can be able to understand what is happening here. So for the other half cycle, when D is positive and A is negative, find that D2 is going to conduct, but when that current reaches this point, it cannot flow through D1, so D1 will not conduct. So that current will take this route and it will flow through this resistor. And when it comes back to point C, it will move back to point D. So you can see that as far as the resistor is concerned, current is flowing through the same direction whether A is positive or negative, current simply flows downwards. You can see that current flows in one direction through the resistor. Whether the current changes direction or not, as far as the resistor is concerned, current flows through the same direction. And that is how we end up achieving full wave rectification using two diodes. So let me look at some further points here that I had written down. During the first half cycle, D1 is forward biased while D2 is reversed biased. I've already explained that. Hence the path taken by the current is A, D1, B, C, A. I've already explained that route. During the next half cycle, D2 is forward biased while D1 is reversed biased, and the path of the current is D, D2, B, C, D. Notice that during both half cycles, current flows through the resistor in the same direction. And that is how we would answer that question. I tend to feel that for you to be able to answer that part of the question, you actually needed to draw this particular circuit, because there is no way you could describe what is happening here without drawing. You must mention the center tapped transformer, the center tapped transformer. So that's it. Let's look at question 10.